Welcome back to part 3 of this 74 Marshall Major. In the last video, I started to remove all the yuck, and after that, I was able to disconnect all the primary connections here for the various voltages that this transformer could be wired at, and the two HT wires, the two blue that were there, which lets me have access to the bottom of the board, as you can see. And I was able to, let me get this out of the way, sorry. Things like to tangle on themselves. What's catching here? Got one more short wire there, but I'll deal with that. This pot wire is underneath the choke connection. Anyway, I was able to get in here and clean this up and clean up these areas here where I'd removed old components. Those 15K pyres did not seem to be original to the amp. They had very strange looking solder joints on the other side. I knew the stuff in the phase inverter was not original. I'm going to show you how I remove such things when I remove this Erie cap down here in the cathode for V1. Right now it is a shared cathode. I'll talk to the owner about whether we're going to do a shared cathode, with just a little more high-end overall than the Superbass, or whether we'll do a split cathode. One of the things that's important to us is not to make any changes that are unnecessary, that cannot easily be redone properly. Later in this video, I'm going to test the output transformer to see if the bias oops here, or the HT B+, the 400 to 500 volts positive DC was tied to what should have been negative 50 volts-ish. Whether that damaged, it probably did kill these two caps here, plus time, but it might have damaged these two output coupling caps in the phase inverter, because they're rated for 400 volts, and they could have had a lot more than 400 volts on them. And it possibly damaged the output transformer. Hopefully, when this happened and the output tubes went up in smoke, the amp blew a fuse and then stopped before the output transformer could sustain any damage, but we can't be sure just yet. All right, this wire right here is running beneath the red and white wires going to the choke, and that's bad for a couple of reasons. First of all, it means I cannot pull the pots fully forward away from all this stuff. Second of all, this has audio signal on it, and it's not really good to run that by the choke wires. So we're going to disconnect this and clean up any residue or flux or corrosion. You can see how it's just kind of tucked in place there. Normally I would do a mechanical joint before soldering, but that's how Marshall did it, and I'm just going to replicate that and move on. And I applied heat to the wire, the conductor, and to the lug, and then brought solder to the lug. I did not put solder on the tip of the iron and then just dab it on like a paintbrush. Anyway, that's a very good joint, and now I can move these pots more fully out of my way because they were tied up. All right, let's remove this cap right here, and I'll show you how I do it without damaging anything on the other side. Put this up out of our way. Kind of bracing the board up with the side of our right hand. Flowing some fresh solder there. And let's see, sometimes the leads are kind of enlarged as they're snipped, which makes it hard to pass through the hole. But now I can see them, and they look just fine. So, if this were a different amp, I could just snip the leads up top, and if necessary, I would. I want to bend these so that they're straight, and I can just push these out. If these leads had been bent at an angle, hooked over, or had any rough surfaces on the outside, I would have snipped the leads at the cap and pushed them down. There we go. Nice cleanly removed capacitor. You can sell that for a lot on eBay. It's absolutely junk. It's 3 years younger than I am. I'm in need of replacement most of the time. So now I like to wipe down the top and bottom with some isopropyl. People ask, I use usually, was it 91%? Just from Walgreens, CVS, whatever. You can buy the really pure stuff for places where it matters. General cleaning up a flux and dirt like that, it doesn't really matter. You don't need to spend any more for the good stuff. Not that it's terribly expensive, but for most of the time, I just use the 91% that's available everywhere, and it works really well. So as you can see, there's no solder, there's no flux, the pads and the traces are undamaged, and when we put the new capacitor in place, all will be well. Looking at the underside of the board, here are where the 10Ks were, well, 15Ks, and they will be again, and those are undamaged. Over here in the phase inverter, there's some damage here on the connections which go to these output ends of the coupling caps. And these coupling caps may in fact be bad, but that damage was not caused by the voltage. The damage was caused by poor work from whoever was piggybacking and just tack soldering stuff to old leads. Just way too much heat was used. And ironically, the best way to burn a board is to use an iron that's not hot enough, because you've got to keep it on there a really long time. I can come back from this because of the nature of these traces. I can actually just kind of like reinforce them as necessary and make it rock solid again. But this is unnecessary work. If someone's not qualified to work on an amp like this, I'd rather they did not, because it just makes it really hard for the next person to clean up their mess. In this case, the next person is me. Such is my lot in life. Down here where the bias resistor is, everything's fine for that one. Here where the diodes were, there's some burning right here between ground. This would be a point that'd be tied to ground, and one side of the HT connections from the secondary, the output transformer, power transformer. But over here where the rectifier diodes are tied together, and this goes to the B+, it seems to have arced and burned very badly in this area to here, which would have been the negative DC. So maybe the previous guy who put the jumper wires up top thought that was supposed to be connected, and he thought he was replicating it. He just made things worse. The issue is that there's a lot of burning, a lot of removed material, and a lot of charring in this area, which means that there is carbon in there, and that it can absorb moisture because the outside protective coating of this fiberglass, which is a form of epoxy, the coating, has been removed, so the bare fibers are exposed, and that can suck up moisture. You can see evidence of that on the other side. I mean, that board is really thin there. It's been worn away, eaten away, and that's the place where there should be no connection, and there is. Even if I don't measure it with a meter right now, that could be voltage present as the humidity changes, and all of a sudden you can bridge from here to here. So I've spoken to the owner, and what we're going to do is notice there's turrets here, here, and here. I can get some keystone turrets, which look very much like these. And I can install 2 turrets here. And I can install 2 turrets here. And 2 turrets here. And tie that over here to this turret, or to a new turret, whatever. And I can use this turret, and put another turret here, and another turret here, and tie that to this cap, and bypass this damaged area of the board. And yes, there'll be some silk screen on the board that's not really indicative of what it's supposed to be, but basically it'll look very factory. So here, 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 new turrets into good parts of the board. And the only issue is I may have to pull the board completely out, which means I have to disconnect it from the pots in order to do the, I could do a press fit. I don't really trust press fits, but swaging it, I'm not sure whether I could probably modify something to sit down on the chassis and then tap it from the top. I'll figure that out. It's hard to do in situ, but that's by far the best option available to us. Other than, I guess I could, if I wanted to save money and make it not quite as nice, I could use some of these holes and just put some terminal strips in and do the diode bridge on a terminal strip. And that's an option. It's just not as pretty as the turrets. But I think this amp is going to be gorgeous when it's done. So I think the turrets are the right way to go. All right, we've removed quite a few resistors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We may put a 2.7K here. That'd be 11. We're not going to use these two, so that takes us back down to 9. But because these two will be replaced by the master volume pot. But the owner needs to decide whether we're going to track down original Pyres, or whether I'll use some modern components of equivalent high quality that just won't be, original Pyres from the era. And that budget is going to be determined by what I do next, which is to measure the output transformer to see if the output transformer is still good. I'm going to do just a DCR test first, because if it fails this, there's not much point going further. This white is the center tap, so I will measure from the center tap to each primary, and should be roughly in the middle. So first, let me measure primary to primary. There's a primary there. There's a primary there. Settles down to about 33 ohms. So I should be seeing about 16 per side. 16.7, 18.6. That all seems very promising. Now, I suppose it's possible for it to have a good DCR measurement and still be bad. It's just very unlikely. I could do a test, I could disconnect everything and plug AC into the secondary, with like 2 to 3 volts AC, and see what measurements I get on the primaries. But I don't think it's necessary, because if these things were going to fail, it would have failed on the primary side, as the output tubes drew way too much current. And I just don't think that would be likely to be a secondary issue. And usually, if you have a bad output transformer, usually you will have a bad DCR measurement. This at least tells me we don't have any shorts. It's possible there's arcing that's not present without any voltage, but I think we can probably go forward with the restoration, assuming that the output transformer is still good. It's just very likely that it is. Let's check the fuses before we end the video, though. Given the nature of the bias cores inside, I'm going to assume that one or both of these are blown. The owner and I were discussing this, and we figured that the most likely chain of events was that someone tried to fix the amp because it had the burnt area in the bias supply, and they, quote, fixed it, and then it immediately blew fuses. Might have done a lightning show on the output tubes, and it just sat. So the HT fuse looks okay. And it's an old one from the period with that string inside. Let's check the mains fuse. I could have just metered this, but I prefer to physically inspect. Yeah, the mains fuse is just vaporized. So that's good. That 4 amp fuse probably saved the original output transformer, possibly saved the original power transformer. If someone had put a 10 amp fuse or a 20 amp fuse, which is a common mistake people make, this would have been a really expensive mistake. So thank you, 4 amp fuse. Thank you for giving your life for the cause. So assuming that the output transformer is good, I think that's a pretty safe assumption. We're going to replace the impedance selector switch. We're going to leave these 2 output jacks. We're going to put a plug in the chassis here per the owner's request. We could leave this jack, but the owner wants it to be very simple. And we're going to put a master volume here. These 2 jacks will be returned with the amp. If someone down the road wants to put it all back, there'll be no permanent modifications. We're going to replace the 1, 2, 3, 4, 5, 6 dual section filter caps with some new F&Ts. We're going to rebuild the bias area with some turrets, the rectification and bias area with some turrets, new components, new bias caps. I'm going to find and price Pyres for all these positions. And I'm going to find and price probably Vichy 2 and 3 watt metal films, both because they are functionally fantastic and because they cosmetically kind of look like the old Pyres, and give those options to the owner. And we'll see whether he wants to go with the modern or the Pyres. And we'll talk about split versus shared cathodes for V1. We are going to remove the ground bus. This would have been a terrible ground bus as implemented, because all the pots which make ground with the chassis were loose. we will improve all that kind of stuff. And down the road, we may look into some shielded input wires and shielded wires going to grids and stuff. But I don't think all that stuff is going to be too terribly unusual to get an amp sounding its best. Shielding was not really a thing in 1974, but it should have been. Looking at the tiny cracks in the epoxy coating on these caps here, I know that is a potential cause for concern because moisture can get into the capacitor through those cracks, but it's not something that I'm preemptively going to say, those all need to be changed. We'll see how they sound. These probably are fine, but it is a possibility that they will need to be replaced due to the cracking, in which case we could track down some other Phillips mustards, or we can do the MKT 1813s. A lot of good options out there. Just something to be aware of as a possibility. I hope that's not the case, but I want the owner to see this and know that, hey, we may do everything else, and this capacitor, it just is noisy, and we have to change it. It's not very likely, but it is a possibility. So I've got some stuff to order and talk to the owner about, and then things will arrive in the mail. I've got to order some stuff from Germany for the output stuff, so this won't be a week or so. Maybe 2 weeks from now we'll resume and we'll have all the goodies. So when people say, hey, where's part 4? When's part 4 coming? It's coming when the parts get here. And I don't have any control of that, but I've got some other amps in the queue until then. So until then, and as always, thanks for watching.